Hi, this is Miss Townsend. In this video, we'll be studying the sine law and the cosine law as part of our trig unit. In the trig unit, we've become very familiar with right-angled triangles. We've learned about the trig ratio, sine, cosine, and tangent, and how to use them in order to find angles or sides in right-angled triangles. However, not every triangle has a right angle. You can see here that these angles are not indicated with that box that tells us 90 degrees. They're just sort of marked, and therefore these are not right-angled triangles. So if you don't have a right-angled triangle, there is no hypotenuse. The definition of the hypotenuse is that it is the side opposite the right angle. Please don't tell me, oh, I was told it's the longest side of the triangle. Eek! I mean, that's a shortcut if you have a right-angled triangle. If you don't have a right-angled triangle, it doesn't matter what the longest side is. It is not the hypotenuse. So no right angle means no hypotenuse. And if there's no hypotenuse, then there's also no side called adjacent and there's no side called opposite. And those are all the things we would need in order to use our trig that we know so far. So no hypotenuse, no adjacent, no opposite. That means we cannot use our trig ratios. Those only work with a 90-degree right angle in our triangle. Not only that, but also we can't use the Pythagorean theorem. So the Pythagorean theorem, c squared equals a squared plus b squared, that can't be used either because that also requires me to have a hypotenuse. So all of those things are out the window, not able to be used if we don't have a right angle. So that's what learning about sine law and cosine law allows us to do. It allows us to work with those triangles that are not right angled. So to start with, is there anything about a triangle other than the fact that there's 3 sides and 3 angles that we do already know? There is one thing, and that is the fact that the sum of all the angles in a triangle is 180 degrees. That doesn't change. That is true for every triangle. So we know that already. That is a piece of information we can continue to use. But obviously we're going to have to learn some other things. So first of all, let's have a look at this triangle. We need to learn how to label a triangle that's not right angled, sort of like in trigonometry, how we started the unit by learning about things like hypotenuse, adjacent, and opposite. Well, those don't exist here. However, if you're looking at this triangle, I want to make sure that you're aware that I agree. If you think that that kind of looks like a right angle, I agree. It does kind of look like maybe that's 90 degrees, but you cannot assume that it is 90 degrees. So unless you are told either in the wording of the question or you are literally given that symbol indicating 90 degrees, you can't assume it's 90 degrees and try to use SohCahToa. So this is not a right angled triangle. So never assume an angle is 90 degrees. So how do we label a non-right angle triangle? Well, the first thing we need to do is we need to give each of these angles a name. So we don't have one angle that's important called theta anymore. We just have 3 angles and we give them a name. And the way that we pick their names is we give them capital letters. So sometimes you'll be given questions where they're already named. And sometimes you're going to have to pick 3 letters. Often I pick A, B, and C. And you have to give each of those angles a capital letter as their name. And then not only have you now labeled the triangle angles, you've actually given the triangle itself a name because this is now triangle ABC. And, you know, in math, we like our written shortcuts. So that symbol, I mean, it's a little triangle. And that means triangle ABC. So this is now triangle ABC. It's customary to write the name of the triangle alphabetically, but I mean, it's not a requirement. If someone said, hey, where's triangle BAC? I'd be like, bro, it's right here. BAC. It's the same triangle. Okay, so we've learned how to label the sides. Nope. We've learned how to label the angles and the triangle itself has a name. But now how do we label the sides? Well, the sides get labels that are the same letters as the angles, but the lowercase version. So when you label a side, so you can see this is called side A. And how did I know that that was side A? Well, this is angle A, and it's always the side opposite the angle that gets the name. If you're wondering why, I mean, to some degree, I wonder too, but I think I figured out why. Because if this is angle A, there are 2 lines or two sides of the triangle that make up angle A. So the angle is between those two sides. But there's no standard on which one of those sides I would call A. So we have to come up with some international standard. How do I know where side A is? Well, we all know because it is defined as the side opposite the angle marked A. So there's angle A, and opposite it is side A. And again, we're using the lowercase letter. So here's side B. Nope. Here's angle B. So if I go opposite it, I can find side B. And here's angle C. If I go opposite that, I can find side C. So this is how you label a non-right angled triangle. We need the angles to all have names, and we need to mark the signs properly. Remember, it's with a lowercase letter that matches the opposite angle. So take a second and make sure you could label the sides of this triangle. We know that first of all, this is a triangle DEF. Again, you don't have to go alphabetically. It's just generally customary to do that. Here's angle D. So if I find the opposite side of the triangle, I can find side D. So this is side D over here. And then here's angle E. So go to the opposite side. This is side E. Notice the lowercase. And if this is angle F, go to the opposite side, and that is side F. So things to remember, because you'll see, we're about to show you the formulas, sine law and cosine law, how important this labeling is. So you need to have names for the angles. If you're not given their names, then you pick 3 letters of the alphabet you like and give those angles capital letters. And then the sides have to be given the corresponding lowercase letter, the opposite side. Okay, so here we are. This, my friends, is the sine law. You might see it written slightly differently. I'm always going to write it like this. And we need to explore what it's telling us. So if I have the sine law where I have A and B and C, so I'm using A, B, C in this version, then it must relate to a triangle that uses A, B, and C. Again, remember, capital letters mean angle, right? So sine of angle A. And you'll notice that each of those pieces, each of these fractions, has the sine of the angle divided by the side itself. So this is sine A over A, and then I have sine B over little b, and sine C over little c. So that's what the sine law is, and that's how you're going to see it written in textbooks. And if you Google what is the sine law, that will probably come up. So obviously we need to know the names of the angles and the sides, as we've been talking about. But I just want to take a moment and explore with you what is happening in the sine law. So let's say that I told you the measure of angle A and the measure of side A. So I knew that sine A should be sine 82, and I knew that little a, side A, should be 16. That's what this would turn into mathematically for this triangle. And further, let's say that I knew about angle C and side C. So if I know angle C and I know side C, I can also say, well, then this must be sine 48 divided by 82. So I've sort of deleted that bit in the middle about sine B because, well, I don't know anything about B. I don't know the angle B, and I don't know side B, so I'm not going to use it. And that's one of the key features of the sine law, is you only actually use 2 of the pieces at once. You never, we know that in an equation you only have one equal sign, so you just use whatever the pieces are that are useful to you at that time, and obviously we'll get into what that means and how to pick. But according to the sine law, this fraction should equal this fraction, right? Because they were equal, even though there was something in the middle, they must be equal to each other. And in fact, if you take your calculator and you calculate sine 82 over 16, you will get 0.619 something, something, something. And if you then calculate sine 48 over 82, you will also get 0.0619. These are equal. So basically, someone long before us went through and discovered this fact that For any triangle, whatever this fraction is, whatever the value of this fraction is, it's the same for every angle and side pair within a triangle. Okay, that's what it is. It's a rule that we know about, that we can use to calculate things in a triangle. For example, let's say that I really wanted to find the length of side B. So I know the length of side C and I know the length of side A, but I don't know the length of side B. How am I going to find it? Now we know we cannot use the Pythagorean theorem. There's no 90-degree angle. So we're going to try to use the sine law. So here's the sine law, and what I'm looking for is this. I'm looking for the length of B. But in order to use that, I need to know what goes on the top of the fraction. So I need to know angle B if I want to find side B. So let's go back to the triangle for a second. I need to find this angle, angle B. And, oh, I know angle A and I know angle C. And if you remember, we know that all the angles in a triangle add to 180 degrees. So I'm just going to say, well, I already know that this is true. I don't know what I mean by that. I already know this fact that I have 130 degrees measured. So angle A plus angle C is 130. And if I then subtract that, I get 50 degrees. That must be angle B. I mean, I haven't set it up in the most beautiful, if you're watching this and you have a different teacher than I, they might want to see a bit more of a sort of nice and professional looking equation. This is what that equation looks like, that all three angles added together adds to 180. I don't need to see that because that's just a simple adding subtracting equation. And so you're probably just going to do it in your calculator anyway. But anyway, however you get there, you end up knowing that angle B must be 50 degrees. So now that I know that this angle is 50 degrees, you'll see that I've now taken my sine equation, my sine law equation, and I've put angle B where it belongs. Now you notice I haven't bothered to put information about angle C or side C, and that's because when you use the sine law, you only use two pieces at once. So because I'm using information about angle A and side A, I'm not going to bother doing anything with sine C. I don't need it. Bye-bye. So now what I have is I have an equation with two fractions equal to each other. And from our study of learning how to do the SohCahToa type trigonometry, we now know that, hey, if I have a fraction equal to a fraction, I can cross multiply. And that's what I'm going to do. Now, it is possible, of course, if you wanted to get a decimal for this and a decimal for this as a starting point. Remember, if you do that, please keep 4 decimals. But I'm going to show you what I prefer to do because it means less time on my calculator and less worrying about rounding. So I'm just going to cross multiply by this, knowing that sine 82 is like a package deal. You can't separate 82 from sine because sine needs an angle. Same thing here. So knowing that those belong together, I'm still going to cross multiply. So B times sine 82 is equal to 16, so cross multiplying the other way, times sine 50. Now that bracket doesn't actually have to be there. It's just for me to visually see that sine 82 is one package and the other thing is, in this case, B. And then how do I solve for B? So here's B. I want it isolated because that means I'm solving for it. And so that means that I need to get rid of sine 82. Sine 82 is multiplied by B. So to get rid of it, I'm going to divide on both sides by sine 82. So this is what it looks like without the brackets. So hopefully you're familiar and comfortable enough with sort of the algebra writing of trig to know that that sine and that 50 are locked in step until you use your calculator. Same thing here. So what having done all of this before touching my calculator means is I can now type this in all at once. I can say 16 times sine 50 divide it by sine 82. Now make sure that you know your calculator well enough to know where you need brackets, if you need brackets, and make sure please you're sort of playing along at home. You should get 12.5. And of course, because I've measured sine length in centimeters, I would say that it's 12.5 centimeters. Okay, so we've used the sine law. Pretty great. Let's do like a full question. So that was me both doing some math with you and also trying to explain what the sine law is all about. But let's just do a question like you might see on an evaluation. Here's a right angled triangle. Nope, not a right angled triangle. Here's a triangle. And I can tell you that the name of this triangle might be, for example, FGH. Don't really need to name it, but why not? I can see that I have the angles labeled as FGH, so the triangle FGH. And because it's not right angled, I'm also then going to immediately label the sides. So this side is angle F, and this side over here is side G. I think I said angle F when I meant side F. You know what I mean? Hopefully you were screaming at your computer, Miss Townsend, you made a boo-boo. Yes, I know. So I've labeled the sides. Let me just clean that up a little bit. This is side F, this is side G, and this is side H. Again, notice this lowercase letters as opposed to the angles, which are uppercase letters. So my goal is to find G, meaning side G. So that's what I want to find. So what do I know about this triangle? Well, I know angle G. That's good. So I know angle G and I want side G. That's great news because it means that I can set up something like this. 1 second. So I can say, well, sine G over G is going to be used in my question. Now, what else do I know? So obviously I know a lot about F. So angle F is known, and so is side F. So in order to do this problem, I'm going to relate sine G over G to sine F over F. Now, I do not care about either angle H or side H, so I don't even need to say equals sine H over H. Though I only want 2 parts at a time, and those are the 2 parts I'm going to use because I have all the information except for sine G. Nope, I know that. I have all the information except for little g. So sine G is sine 45 over G. So sine G over unknown G equals sine F. Angle F is 115 and side F is 8. And so again, even though G is right there, I'm just going to cross multiply. Again, remembering I don't have to use my calculator until the very end if I do it this way. So I'm doing G times sine 115 and I'm doing 8 times sine 45. Just a quick note here. There's a reason in particular why I didn't want to do sine 45 times 8. Of course, that means the same thing. However, if I write sine 45 times 8, I'm clearly going to need some sort of indication between them so that I don't think it's sine 458. So now I have to introduce like a multiply to mean that, but then it's still not clear to me if that's 45 times 8 or sine 45 times 8. So we tend to prefer to write our multipliers out front of our trig statement. So that's why I did that, and I encourage you to do the same. Or you can always use more brackets than I use. That's fine. So where are we? So we're trying to solve for side G. And right now G is multiplied by sine 115. So I want to get rid of sine 115. And of course, the way we get rid of something that's multiplied is we're going to divide on both sides by sine 115. So I have sine 45 over sine 115. And then when I type that into my calculator, I get that G is 6.2 centimeters. And that makes reasonable sense with what's happening in the diagram. So that is a typical sine law question. Here's another one. I encourage you to press pause and try this one on your own. Okay, so I have triangle MNP. There's no right angle, so I'm just going to label the sides. This is side M. This is side N. And this is side little p. Okay, so what am I trying to find? I'm trying to find side P. So side P, it would be this one. So in order to find side P, I need to know angle P, but I don't know it. But don't I? Because if I have two angles in a triangle, I can always find the third because all angles in a triangle add to 180. So that's the first thing I'm going to do, and I'll do it the more, math teacher friendly version. I'm going to say that 180 is equal to all the angles, 56 plus 42 plus P. And then if I solve for P, I would get that P has to be 982. So these two together add to 98. Subtract, I get that P is 82. So now I know that angle P is 82 degrees. So I know I'm going to be setting up the sine law with P. So sine P over little p equals. Now, I need to find another letter where I know both the angle and the side. So I do know both angles M and N, but I don't know side N, which means I'm not going to use N, sine N over N. I am going to use M. So I am going to take the values of angle M and side M, so M, and I'm going to continue to write the sine law. So sine M, which is 56, over 111 side M. So I've just taken the information from the triangle and I set up the version of the sine law that I need right now, which is P over P, M over M. And now I'm going to cross multiply. So I've got 111 times sine 82. And I've got P, little p, times sine 56. And then I want to solve for P, so I need to get rid of that. So on both sides, I need to divide by sine 56. And then when I type all that into my calculator, I will know the length of side P. So I get 132.6. And it would be measured in meters because that's the side length I'm given. And 132.6 kind of makes sense with a diagram. I could never measure a diagram in high school, but I can approximate it. They should be reasonably accurate. So that is the length of side P. So now look at this question. It says find, what does that say? So just in case you haven't seen this before, there's a symbol here in front of B. Now we know that that capital B means angle B. Capital means angle. But just want to draw your attention to this symbol. That symbol means angle. And I know for some students, it can look a lot like the less than symbol, but this is meant to be like this edge is meant to be sitting on the ground as opposed to both of them being at an angle. So it's a subtle difference, but I mean, obviously context is important, right? I mean, we're in the trig unit. Why would I suddenly say find less than B? That would be a very strange statement to make. So that's what angle, that's the symbol for angle, which means that in this question, we are trying to find angle B. So let me go away that message. Okay, so I want to find angle B. Let's see what we can do. So first of all, I'm going to label the sides of my triangle. So here is angle A. So this is side A. Here's angle B. So this is side B. And here's angle C. So this is side C. And I like using my highlighter here. So I know angle A and side A. Great. I know both pieces of A, so I'm going to use that. My goal is to find angle B, and I know what side B is. So this time you can see it's sort of turning it a little bit backwards. I'm looking for an angle instead of a side, but the sine law stays the same. I just this time know an angle and not a side. So I'm going to be using the sine law using A and B. So sine A over A, so angle over side, equals sine B over b. So notice this time it's capital B, the angle that I don't know, but it's the same sine law, and I'm still just going to cross multiply. So I'm going to do 18 times sine 109. And I'm going to do 23 times sine B. So I know right now I have 23 sine B, but first let's get rid of the 23 and then we'll get rid of the sine. So I can't get rid of them both. I mean, you can when you get really used to things. But first I'm going to divide everybody by that sine 20, by that 23. Get rid of that, so I'm left with just sine B. And that would give me, oops, wrong tool. That would give me 18 times sine 109 divided by 23 equals sine B. And you're certainly welcome to calculate what this is right now in your calculator. But you could also wait. But I'll do it this way for now. This is basically, if you're rounding, you end up with 0.7400 because it was 0.73997 or something. But I'm not done because I didn't solve for B yet. I found sine B. So now we have to get rid of sine. And the way to get rid of sine is to do inverse sine, or you may have heard the phrase arc sine. So I think of it as, okay, how do I isolate B? I move sine to the other side. That's a weird thing to say, but it just fits with all my other equation solving. What happens when I move sine over? Well, it becomes inverse sine. And this is now what I can type into my calculator, and I get that angle B is 48 degrees. And again, you don't need to write that. You can just say B equals, because you and I both know capital letter B is an angle. So it is 48 degrees, and when I look over here, that seems pretty reasonable. So try this question. I encourage you to press pause. We need to find angle Y. So what do I know? First of all, I'm going to label the sides, always a good first step. So this is side little z. This over here is side little x. And over here we have side little y. And I need to find angle y, so I'm glad I have little y. So I have y, and I want y. So I know y is going to be used in my sine equation. And the other thing is, I also know x, the angle, and x, the side. I don't care about z. Z, irrelevant. I need these two pieces. So now I'm going to set up the sine law using this information. So I have sine y over the side length y equals sine x over side length x. And just like before, I'm now going to cross multiply. So 3.2 times sine y equals 2.5 times sine 71. Now I need to get rid of this multiply by 32. So on both sides, I'm now going to divide by 32. So I have sine y equals 2.5 sine 71 divided by 3.2. And again, you certainly at any point you could have started using your calculator. I'm going to now wait till the very end to use my calculator, which means my next step is that I'm going to get rid of sine because I want y. I don't want sine y. I want y, which means I need to do inverse sine on both sides. So it looks like this. Sine inverse of 2.5 sine 71 over 3.2. And I know my calculator really well, so I know that I can pretty much type this in exactly as it appears. And then it'll just tell me what y is, and I won't have to worry about in between steps where I've, where I've rounded or whatever. So when I calculate y, I get a value of 48 degrees. I hope that's right. Isn't that what we got in the last one? I think they're both 48 degrees. I guess I like that number today. So I hope you got that. And, well, now here's another question, and it looks exactly the same except for the instructions. The instructions say solve the triangle. So remember, solve the triangle means find all the angles and all the side lengths. So This is the exact same triangle we just had. So first of all, we already know what angle y is. We just did that calculation. I'm also going to put back on here the side name information. So this is little z, this was little y, and this was little x. So what do I need to find? Well, I need to find, I've got a lot of information, but I don't have all of it. I need to find this angle, and I need to find this side. Because I have angle y, side y, angle x, side x. So I can find angle z pretty quickly because we know that all the angles in a triangle add to 180. So 180 degrees must be 48 plus 71 plus whatever z is. So I'm going to calculate angle z. I put that little bar on my z's. So angle z must be 61 degrees. And now that I know angle z, I can use it to find sine z using the sine law. So sine 61 over lil z must be, and here I can choose to use either the x information or the y. I'm going to use the x information just because it was given to me, so I know it's definitely correct. So I'm going to use sine 71 over 3.2 like we did in the last slide where we used that information. So sine 71 over 3.2. And again, we're cross multiplying. So this is little z. Z is one of those numbers that unless I were to go totally old school and write my z in script form, which I haven't done in about 30 years, it's kind of, it's just to me, I mean, without lines on the page, is that not like just a crazy 3? So I'm just going to use z. I know it's little z because A, I know big Z, and also it's in the bottom of my fraction. It doesn't have sign beside it. So there's all kinds of context clues for those letters that don't really have a different big form versus small form. So 3.2 times sine 61 equals z times sine 71. We're going to divide both sides by sine 71. So 3.2 sine 61 equals sine 71. All of that will give me side z. So if I type that into my calculator, I get that z is, well, it says 2.96 something, so it's basically 3.0, and we are measuring in kilometers. So side z, little z, is 3.0 kilometers. So don't forget, we still have this thing sometimes called solve the triangle, where you're not just finding one thing, you're finding all the things. But not every triangle gives you the information you need for sine law. Have a look at this triangle. So hello, this is triangle EFG. And we can label the sides. So we have sides, this is little e, this is little f, and this is little g. But you'll notice that I do not know both angle E and side E. I do not know both angle F and side F. I do not know both angle G and side G, meaning I don't have a complete pair of angle and side of the same letter. I don't know both pieces. And if I don't know both pieces, I can't use the sine law. Uh-oh. It doesn't work. You have to have one of these fractions completely known to set up the sine law and use it to solve. Which means there's something else. It's called the cosine law. Hooray! So you can see the cosine law right here. It's called the cosine law because of this little one moment of cosine. So c squared equals a squared plus b squared minus, it's a long law. You will memorize it by the time you're done a couple practice questions. But that is the cosine law. And that is what we use if we can't use the sine law. So how does it work? So it's important. This one can be yuckier to calculate. So obviously we still have capital letters that represent the angles and little letters to represent the sides. And the most important thing about using the cosine law is understanding how to set up what goes out here. That is a C, which is the same letter that we're doing the cosine of. So one of the most important things about using and setting up the cosine law is that you have to match these two letters. So this is side C and this is angle C, and they have to be the same letter. Now the other two letters are both lowercase, so they're both sides, and they're just the other sides. So angle C is important. It tells me that side C is important. And then the other two sides are just coming along to do the math for us. So that's really important, is setting it up properly based on what is the angle that you know. So what you need in order to properly use the cosine law is, therefore, you need to know one angle and the sides surrounding it. So that's not a very good drawing, but I don't edit my videos, so you love it. So you need to know an angle and the two sides surrounding it, or I think of it as the two sides that are hugging your angle, because I like that. So let's look at how to use it. So first of all, not a right angle triangle. Let's label the sides, and then we'll figure out where to go from there. It's always a good, you always want a starting point, right? Start there, label the angles, label the sides. This is angle E, so over here is side E. This is angle F, so this is side F. And this is angle G, so boom. So I do know one and only one angle. I know angle E, but I don't know what side E is. However, I also don't know any of the other angles, so I can't use the sine law. I do not have E with E, F with F, or G with G. But what I do have is one angle, and I know the length of the two sides that form that angle, or hug that angle. So 58 is being hugged by little g and little f. So that means I'm going to set up my cosine law using E as the important letter. F and G are just the other letters. So this is what my cosine law normally looks like, right? That's the way it's written in textbooks, and you're given this on evaluations probably. But it's important to say, how do I adjust it for my question? Well, we know that we are going to be using angle E. It's the only angle I have. And that means that this has to be side E squared. And then the other two letters, well, they're just going to be F and G. Small case because they're sides. So this is what this version of the cosine law would be in this question. So we have to be finding E because that's the angle. So angle E means we're looking for side E. And then the F and the G are just the other two pieces of information that go into that equation. So once you've set it up properly using the names of what you have, we can start substituting in and talking about how to calculate it properly. So side F, I lost my labels here. Here we go. So side F is 21. So that'll be F squared, 21 squared, and then 16.5 squared minus 2. That 2 is just part of the equation, times 21 times 16.5. And I always put a bracket here. It depends on your comfort, but that means multiplied by cosine of angle E. So that's just substituting in. So what's really important, and having taught for a long time, I've seen a lot of cases where students are fine, they're doing well, but for some reason the bedness of this equation messes them up. All of these values that I'm highlighting need to be multiplied together. So I'm going to just show you how I like to do this math and how I recommend. Oh, interesting. I don't know what I just got there. Okay, fixed it. Woo, fixed it. Don't edit my videos because I don't have the time or really the technical ability. Someday, maybe. So here's how I recommend you calculate. I do, in my calculator, 21 squared. I'm literally grabbing my calculator here. So 21 squared is 441 plus 16.5 squared, which is 272.25. And then I put the minus, so I carry this minus down, and I put a bracket. And then in my calculator, I multiply all those things that are highlighted together. So in my calculator, I do 2 times 21 times 16.5 times cosine 58. And again, make sure you know your calculator. When do you need, can you do this all at once? Do you need brackets, etc.? So all of that math together gave me 367.2341. I'm keeping our 4 decimal for trigonometry rule. And then now I'm just going to come along and I'm just going to do 441 plus this number minus this number. So I'm just literally typing that in. 441 plus 272.25 minus 367.2341. And that gives me, get my pen back, 346. Did I, if you're practicing along with me, did I mess you up there? 346.0159, but of course that's not e, that's e squared. So now I need to take the square root of this number, and square root of that answer is 18.6. Again, 1 decimal place in your answer. Oops. Let me go back there for a second. So 1 decimal place in your answer. So it is 18.6. We are measuring in centimeters. So the length of side E is 18.6 centimeters. So I encourage you to press pause and see if you can do this question without me. Okay, so I'm going to label my sides. This is side little t. Over here, this is side little u. I don't know why I'm making it so fancy. And then this is side little v. I mean, if you're writing on line paper, it's clear what a big letter and a small letter is, but, you know, little u. Anyway, you know what's happening. And then I'm trying to find side t. So I want to find side t. Oh, why did I do that? Excuse me. Get rid of that. Yay, I did it. Okay, highlighter. Okay, I want this, and I know this. I know angle t. But I don't know any of the other angles, which means I can't possibly use the sine law. So what I have is angle t and the 2 sides that are surrounding angle t. I know this side, I know this side, and I know the angle that they're hugging, which means this is a good cosine law question. So I need to make sure I set up the cosine law properly. So the cosine law in this case is going to involve angle t, which means side t is what it's equal to. Now the other 2 sides are u and v, so u squared plus v squared minus 2u v cosine capital T. So again, we make sure that we have the capital here equal to the lowercase here, and then the other information is the other 2 sides. Oh, I just erased all of that. Oh, good, I found it. So here is what you should have back. So I put it slightly higher than where I actually wrote it. Planned ahead, didn't quite remember. This is the version of the cosine law that we're going to use. And so now we're going to sub in what we know. And we know everything except for that little t. So we're just going to sub in t squared, because I don't know what t is yet, but u squared. So this is side u is 20 squared. And then v squared minus 2u times v times cosine 100. It really doesn't matter if you did 16 times 20 and 16 times 20 here. I mean, it's the 16 and the 20 could be reversed and it wouldn't change anything about what you're doing in the question. So again, how should we calculate it? So my recommendation, I'm going to do 20 squared. I'm going to do 16 squared, which I don't remember what that is. 16 squared is 256. Oh, I should have known that. Minus, and then I put a big bracket. So the minus sign gets carried down. 2 times 20 times 16 times cosine 100. Now, the reason why I put that bracket is really significant now. I get negative 111.5 0.1348. 1348. So this is 111. They kind of all got merged together. But what's important, really important here, is to notice that the calculation here, sorry. Don't like that. Okay, let's do this. Okay, we're here. Let's just pause for technical issues here. Okay, so the calculation we did here, when we multiplied 2 times 20 times 16 times cos 100, actually gave us a negative number. That's why that bracket is really going to come clutch. Why I've always told students put that bracket in, because we are subtracting, that's from the formula, a negative. So that bracket gives me no doubt that this is going to end up being plus, because subtract a negative is a plus. And just so you know, that's going to happen anytime you take the cosine of a number bigger than 90 degrees. That's just a fact. You will learn so much more about that in grade 11. But for now, we just trust our calculator because our calculator knows what's going on. And now I'm going to do the math I have in front of me. I'm going to do 400 plus 256 plus 111.1348. So what do I get? $256. So we get 767.1348. And then, of course, I need to take the square root of both sides. And when I take the square root of that 767 number, I get 27.7 centimeters. Centimeters because of this. And that makes sense. 27.7 is the longest side. And again, we've talked about this before, but what if instead of saying just find little t, which we just did, what if instead I said solve the triangle, find everything? So we just discovered that this is 27.7 centimeters. We don't need to recalculate that. So I know all the side lengths, which means what I'm missing is the angles. So I'm missing the measure of angle U, and I'm missing the measure of angle V. So now that I know t, the angle, and t, the side length, I can use the sine law. So you never need to use the cosine law more than once in a question, because I now know, after using the cosine law, that I can set up the sine law with sine 100 over 27.7. And then, well, what am I going to put here? U or V? It doesn't matter. Pick one. Just pick one. I'm going to use U. I don't know why. U. So sine U over 20. And then, just like we were doing with the sine law, we're going to cross multiply. And we're going to get 20 sine 100 equals 27.7 sine U. Divide both sides by that 27.7 number. And then do the inverse sine on that. So I'm removing the sine now, moving it to the other side, inversing it. Oh, my handwriting is just yucky right now. And then I just have to type that into my calculator. And I get that U, angle U, I'll just use that symbol for, I don't know, because I can. Angle U is 45 degrees. And now that I know that angle U is 45 degrees, I could use the sine law again. I could use sine 100. I could use sine 100 over 27.7 equals sine V over 16. Or I can use the fact that I now know two of the angles in my triangle, and I can just find angle V using the 180 rule. So 180 is 100 plus 45 plus whatever angle V is, and therefore I can calculate that angle V must be 35 degrees. Now, we're not quite done talking about our friend the cosine law, because this is the cosine law. Yes, miss, we've learned that. Thank you. However, sometimes what you need to do is figure out an angle. And if you know the length of the sides, so if I know the length of side A, side B, and side C, in other words, all three sides, then I should be able to use this equation to find that angle. And in order to do that, I'm going to show you the rearranged, or as I call it, backwards cosine law. So imagine starting here and trying to solve for angle C. I would subtract a squared on both sides. I would subtract b squared on both sides. I would divide by this negative 2ab. And that gives us this, exactly that. So I had c squared, I subtracted a squared, I subtracted b squared, and then I divided by negative 2ab. That is fine, but I actually prefer to go all the way and also get rid of the cosine that's happening to my angle I'm looking for. So this is the way I like to actually present the cosine law, which is to find angle C, you do inverse cosine on whatever this math is when you calculate it. And so what's really important here is that the angle you're looking for, so the angle that you want to find, is the angle that you've put first in that numerator. So all the other sides, so angle C has to match side C, and then the other sides are A and B, and they go in just those other places. They don't get that prime position. They just fill out the rest of the formula. So, when do you use the cosine law? You use the cosine law when you know all three sides but no angles. So this version of the cosine law will allow you to find one angle if you know all three sides. So for example, let's look at this problem. I want to find angle M. So here's angle M. And I know all three sides of the triangle, which means I can use this backwards cosine law that we've just discovered. However, I have to use the backwards cosine law using these letters. So this is side M, this is side P, and this is side N. Now I circled side M because it is the important side. It's the side opposite, sharing the same letter as the angle I'm looking for. And that means that when I try to find angle M, so I'm capital letter, big giant one, I need to make sure that in my bracket, I start with little m. Now the other two sides can go wherever they want. So it'll be minus p squared minus n squared, and then divide it by negative 2pn. That is how you set up this backwards cosine law for this triangle to solve for m. So now I'm just going to sub in the values that I know. So m squared, that would be 130 squared, minus p squared, 170 squared, minus 145 squared, divide it by negative 2. Oops. 1 second. We're back. Negative 2 times p times n. And of course, these are all side lengths. And then my recommendation, I actually find this one easier to calculate, is just calculate the entire numerator in one step in your calculator. I get negative 720. Calculate the denominator in one step in your calculator. I get negative 960. And then I just literally type into my calculator exactly what I have, inverse cosine of this bracket. And I get that m is equal to... Now, hold on. I did that math wrong. I apologize. I was distracted by my phone ringing. This is not the same question I'm looking at. Okay, let me try that again. Okay, 130 squared minus 170 squared minus 145 squared. I get a very different number. I get negative 33025, and then the denominator, negative 2 times 170 times 145 equals negative 49300, and then I type all that in all at once in my calculator. I mean, you can certainly simplify the fraction first, but I don't need to. I mean, I'm probably not going to type the two negatives because I know that a negative divided by a negative is a positive, so that would seem a little silly. But sometimes, you get, robotically, let me just finish the question. So I get 47.9, which is 48 degrees. And once I know angle M, I can use the sine law again. So now that I know that that's 48 degrees, I could, if I wanted to solve the triangle or find something else, I could set up the sine law using M. So take a moment and try this question. So this question asks us to find angle H, and I don't know any angles. So if all I have is side lengths and I know none of the angles, then we know that we are going to be using, hold on, technical glitch that I want to check on here. I know that I'm going to be using the backwards cosine law because all I have is all the angles, and therefore I am going to use the backwards cosine law to find what I'm looking for. And in this case, of course, what I'm looking for is angle H, which means that side H becomes the important side. And when I'm setting up the cosine law, I'm going to use, therefore, H, side H. Nope, that's angle H. Angle H, and then inverse cosine, and then this big bracket. So side H gets priority. The other two sides are just side F and side G. Doesn't matter which order I put them in. And then -2, this would also be FG. Again, it doesn't matter the order. So once I've found the version of the cosine law I want, I'm going to start subbing in. So this is 23 squared minus 32 squared minus 15 squared. Divide it by -2 times 32 times 15. So again, I like to calculate the entire numerator as one calculator moment. This is where I get -720. And then the denominator is -960. I knew those numbers were familiar. And then in my calculator, I can just type in one step, inverse cosine bracket, and do this math. I get that H is 41 degrees, and I hope you got that too. So here's the key learning related to sine law and cosine law. The sine law is used if you know one angle and its corresponding side. So you need to know one complete pair of letters. The cosine law is used if either you know two sides and the angle between them, that's the regular cosine law, or if you know all the side lengths and none of the angles, then you can find an angle using what I call the backwards cosine law. And that's it. What are the next steps? Well, the only thing we have left to do is practice this math. So please make sure that you are practicing. I usually have an end slide that says practice. It seems to not be here. So practice the math. Ask for help in person if you need it. Stop relying on AI as if AI is a teacher. AI is a tool. It's not a teacher. There's a huge difference. And take care. Thanks for watching.